This is the scenario that is described to us by the question, and because this is the line y is equal to x and this is the line y is equal to minus x, so it is going to be 45 degrees here and 135 degrees here. That makes this angle here 90 degrees. Let us try to find the area of this triangle OAB. So, and to do that, I'm going to first find the coordinates of A. To find the coordinates of A, y is equal to x. So if I were to substitute this into this equation here, that means p squared plus 1 of x minus p squared minus 1 of y. And because y is equal to x, so of x is equal to 4p. And if I were to solve for this, on the left hand side, I'm going to be left with just 2x is equal to 4p. So x is going to be equal to 2p. And because y is equal to x on this line, that is why y is also going to be equal to 2p. So the coordinates of A is going to be 2p, 2p. And at point B, that is when y is equal to negative of x. So if I were to sub it into here, that means p squared plus 1 of x minus p squared minus 1 of y, which is minus x, is equal to 4p. And if I were to try to solve for x, what I'm going to get on the left hand side is 2p squared x is equal to 4p. So x is going to be equal to 2 over p. And y is equal to minus x. So y is minus 2 over p. So the coordinates of point B is going to be 2 over p and minus 2 over p. Now we can find the area of the triangle OAB. And to do that, it is pretty simple because this is a right angle here. That is why it is just OA times OB. So the half of OA times OB. So half of OA times OB. So it will be half of OA. OA, I'm going to make use of the Pythagoras Theorem, or the distance between 0, 0 and 2p, 2p. That will be square root of 2p minus 0 square plus 2p minus 0 square. Multiply by OB, and I'm going to do the same thing. I have the coordinates of B with reference to the origin O 0, 0. That is going to be 2 over p minus 0 square plus 2 over p minus 0 square. Sorry, minus 2 over p minus 0 square. So this is going to be equal to half. Square root of this is going to be equal to 8p square. Square root of this is going to be equal to 8 over p squared, which means that what we have is a half square root of 8p squared multiplied by 8 over p squared. So the p squared and p squared can be cancelled, so I have half of square root of 8 squared, which is half of 8. So the area is 4, and this is going to be an area that is independent of p, which is what the question wants us to show.